Temperature also affects gas volume. A gas contracts when cooled, and expands when heated, which gets us to Charles's law. The volume occupied by any sample of gas at constant pressure in moles is directly proportional to its absolute temperature, meaning the Kelvin scale. Volume is proportional to temperature at constant number of moles and pressure, meaning V over T is equal to some constant. So the more usable Charles law is as follows. V1 over T1 is equal to V2 over T2. Realize that temperature must be in Kelvin, and this also is true at constant number of moles and pressure. Let's look at an example. Sample of methane gas has a volume of 3.8 liters at 5.0 degrees C. It is heated to 86.0 degrees C at constant pressure. Calculate the new volume. We assume constant number of moles of gas since there is no evidence of gas escaping. Since we are at constant pressure, it allows us to use Charles's law. We know that the temperature and volume at a given pressure and a new temperature later on, so we can easily solve for the new volume. We'll call 3.8 liters volume 1. We'll call 5.0 degrees C temperature 1, which we got to realize we're going to have to change that into Kelvin, which is 278 Kelvin. And we'll call 86.0 degrees C temperature 2, which once again we're going to have to change that to Kelvin. 359 Kelvin. So we have our Charles law, V1 over T1 equal to V2 over T2. We rearrange the solve for the new volume, V2, and using Kelvin temperatures we obtain V2 is equal to V1 times T2 divided by T1. V1 we said was 3.8 liters. T2 is 359.2 Kelvin. And T1 is 278.2 Kelvin. Our Kelvins cancel, leaving us our final answer of 4.9 liters. Note you must use Kelvin temperature. That's your degree C plus 273.15 Kelvin. And second, since the temperature increased, we know the volume will also increase because they're proportional. So we anticipated the volume to increase, which it does. It goes from 3.8 liters to 4.9 liters because the volume increased as well. The temperature increased as well, going from 5 degrees C to 86 degrees C. Homework 39.